Okay, this is an example of how you'll want to run a correlational analysis for your assignment in week 3. So I'm going to run through this, how to do it and how to look at the data to make sure that you get through your assignment very well. So the first thing that I have done is I've set up hypotheses for a correlational test. Where I'm extracting my data from is a evaluation of a peer recovery program where participants were going through a series of peer recovery over a 3-year period. But what I'm interested in is whether symptomology as measured by DSM symptoms is associated with quality of life. So I've set up a null and alternative hypothesis to test this. The null hypothesis is DSM symptoms is not associated with quality of life. My alternative hypothesis is DSM symptoms is negatively associated with quality of life. Now, as I put in the announcement for this weekend, when we're looking at a correlation, we want to look at 3 specific things. If there's a direction for the association between the variables, the strength of that association, and whether the p-value is significant, meaning that the p is less than 0.05 by scientific standards. Now, I want to remind you that you need to incorporate what you've learned so far, so we need to make sure we include any mean, standard deviations, and sample size into our reporting of our correlation. So the first thing we need to do is we need to look and make sure our statistics have no outliers, that it's normally distributed. And what I'm going to do is just show a really basic way that you can basically test for that. In later weeks, when we look at ANOVAs and more complicated processes, we'll actually look at different tests we can do for these. But this will kind of basically show what we're looking for. So in order to do a correlation, we need to make sure we have the right scaled variables, which DSM symptoms is measured on a 0 to several symptom scale with severity, and quality of life is a standardized measure. And so we know that we have at least a scaled version of our data. So what we want to look at is their distributions and whether their means and medians are similar. So what we're going to do is we're going to go to Analyze, and we're going to go to Descriptive Statistics, and we're going to select Frequency. The variables that I'm interested in is I'm going to use DSM symptoms in time 1, and I will use quality of life symptoms in time 1. I'm not interested in the frequency table, so I'm going to deselect that and just hit OK. And I'm going to ask for statistics. I want the mean and the median, and this is all we'll look at right at the moment. We can also, if we want to, let's select skewness and kurtosis. And we're going to go ahead and hit Continue. I'm also going to select Charts, and I'm going to ask for a histogram and to show the normal curve. I'm going to hit Continue, and I'm going to hit OK. And so, as we can see, our means and medians for both statistics are fairly close. We have a slight skewness on our DSM scale and very little on our quality of life. And so we're going to go ahead and look at the statistics. You can see on the DSM scale that it is slightly skewed, but in general, it's a very small skewness. In our quality of life, we can see that it pretty much fits the normal curve. We do have one spike here, but in general, our population, or sample, I should say, is heading towards normality. Okay, so from this point, we can pretty well assume to some degree of confidence that we can go ahead and run a correlational analysis. Now, if these were extreme, like for example, the skewness on DSM, if we had a whole bunch over here and it just suddenly sloped, then we would probably want to work with that data a little bit more before we trusted any of the correlations that we'll run. The second thing I want to do is I want to look at the data visually before I run the actual correlation, just to see visually what this relationship looks like. So what I'm going to do is I'm going to create a scatter plot that is going to plot the scores of DSM to those of quality of life. So I'm going to go up here and I'm going to hit Graph. I'm going to hit Chart Builder. On this, you can hit this and hit OK. And we're going to go down here and we're going to select Gallery, Scatter Plot. I'm going to make sure this is up here. And you can already see that I have it set up. So we have DSM on this one, quality of life on this one. You do this, I'm going to put this out here. You do this by taking, for example, the DSM and just putting it over here, okay? And I'm going to go ahead and hit close on that and hit OK. And this is what we come up with. So the next thing I like to do is I'm going to click on this and I'm going to hit this fit line right here. And I'm just going to go ahead and hit close. And I'll hit close on that. And you can see that it put a line on here. Now, what we can see in general is this general trend of as scores on the DSM are high, they tend to be low on quality of life, meaning that it's sloping towards a negative direction if we look at these top ones here and these bottom ones here. And as we can see, we do have a best fit line that slopes in a negative direction. And so what we can tell from this is that we do have some scatteredness. So any correlation on a linear fashion is probably going to be on the small side, but we have this general negative trend. Now, so we're pretty sure that we're going to see a correlation. But the reason why you want to run a scatter plot before you do your actual correlation is to make sure that the data looks linear. For example, we could have a whole bunch of scores here, here, and down here, which would mean that we have a curvilinear relationship. And so the importance of a scatter plot is to make sure that you have a linear trend, because with that example I just used, you wouldn't have a linear relationship and you would assume that your correlation will be 0 and that there's no association between variables, when actually you do have a relationship, it's just not linear. And so that's the importance of running the scatter plot before you run a correlation, an actual correlation. So now that we see that there is a general linear relationship, we can go ahead now and run our correlation. So again, I'm going to go back to my hypothesis, and you'll see that I'm predicting, or my alternative hypothesis would say that there's a negative relationship between DSM symptoms and quality of life. So I'm going to keep that in mind, and I'll show you why here in just a second. So I'm going to go up here, I'm going to select Analyze, and I'm going to come down to Correlation. And the type of correlation I'm doing is a bivariate, meaning that I'm associating two variables with each other, hence the word bi, and then variate meaning variable. And then I'm going to come down here, I'm going to select DSM time 1, and I'm going to select quality of life time 1. I'm going to run a comparison, but when it says test for significance, if I wasn't predicting the direction of a relationship, I would use a two-tailed test. But since I am trying to predict one direction, meaning I'm looking for a negative direction, I'm going to select one-tailed test. I'm going to come up here and I'm going to select options, and I want it to report our means and standard deviation, and I'm going to hit continue. Now I'm ready to run my basic correlation. So I'm going to go ahead and hit OK. And we're going to start with this first plot. So we can see that the DSM for time 1, the mean score was 28.01, and the standard deviation is 17.03, and that there was 112 valid cases that could be analyzed. And quality of life for time 1, the mean is 74, and the standard deviation is 17. And that the valid number of cases was 140 in time 1. Now, let's go ahead. Now, we want to report these within our description. The second thing we're going to look at now is the correlation itself. As we can see, when we correlate DSM with DSM, we get a perfect 1, meaning, and that's pretty common sense. Quality of life is going to be associated with quality of life perfectly. So the box that we're interested in is DSM correlated with quality of life. And the first thing that we want to do is first look at direction. We can see that it has a negative sign. So we know that there is a negative association, meaning that as one score goes up, the other one goes down, and vice versa. And so we now have established the direction of the relationship. It's a negative direction. If there wasn't a negative sign, that would be a positive correlation, meaning that as one score goes up, the other score goes up in general. So now that we have the direction of the relationship, we want to then look at what the strength of the relation is. Remember, the strength is measured from 0 being no association to 1 there being a perfect association between the two variables. In this case, we have a 0.362, and we'll just round that to 0.36. So the strength for our association is weak to moderate, at least for social sciences. Most of social sciences will range between 0.4 to 0.7, in psychology around 0.4 to 0.8. But 0.36 would be kind of a weak to moderate relationship, meaning that it's there. We saw it in our scatter plot, but it's not anywhere near a strong correlation. So in your write-up, you would want to put R equals negative 0.36, which is a weak to moderate association between these two variables. The next thing we want to look at is whether or not the significance level is less than 0.05. And we can do this two ways in our correlation box. One, we could look at whether there's stars here that are asterisks, and we could note that there's 2 of them, which says that the correlation is significant at less than 0.01 level on our one-tailed test. That means that we're definitely below 0.05. And we can also look at just the significance level where it says 0.000. This denotes that our p-value is less than 0.05. So we can say that the correlation is significant. And so what we have, if we were to summarize our findings, is we have a negative correlation, which is weak to moderate, between DSM symptomology and quality of life. And the alpha level, or p-value, is less than 0.05, so I am confident that this statistic represents the population for which this sample comes from, at least from a probability perspective. So in this case, I could confidently reject the null hypothesis that DSM symptoms is not associated with quality of life, for the alternative hypothesis that there is indeed a negative association between quality of life and DSM symptoms. Now, the other important statistic within the correlation box that you want to note is the sample size that we could have for this correlation. You can see that only 112 of the participants had both a DSM score and a quality of life score. And that's kind of important to keep in mind, because that means that approximately 28 of your participants that had a quality of life score were excluded from this analysis. And so that's something that you would want to note in your descriptive statistics. So that ends this. In class, I hope we have time to look at how to write this up. But for now, I think this video provided you with kind of how to run this for SPSS.